be taking you through building an AI resume generator. Today we are going to be, working on a RAG project, which is, like I said, an AI resume generator. So let's say, for example, what we are building is this. For example, we have a candidate that gives us their CV. We are going to read it. Uh, we read it to break it into chunks. We are going to find the most important or relevant parts of that CV for a particular given job description. So that's what we are going to do. So this is useful for a situation whereby an organization that is trying to recruit quite a number of people. You've had maybe hundreds of CVs. Instead of going through them one by one, so you can always extract important part of the CV that fits the job description. So that's what we are going to be doing. Now, the first thing we are going to do is to import required libraries. Okay, so here we are first thing is to import necessary libraries. Okay, so here we import OS. The next thing is you'll be using Anthropic. Imports ChromaDB. So be using Anthropic as the LLM, that is going to be powering this RAG. Then ChromaDB is the database. Okay. Then also you are going to import PDF reader from pypdf. Okay. So okay. So now that we have imported the CV, we are going to put in a particular job description. So let's say, for example, we are trying to employ someone who is an AI engineer, right? So let's say job description equals to. So we have a multi-line string here. So multi-line string because we are going to be writing a job description that is going to span across multiple lines. So you can have something like um, AI engineer. Okay. You can see we are looking for an AI engineer uh, to join our team. Okay. Okay. Responsibilities. So you can say, for example, he's going to be responsible for designing and deploying your ML models for maybe fraud detection and risk scoring. Okay. You can also see maybe what else can we see on? You can see maybe building scalable pipelines, something like that. Scalable pipelines. Okay, for model training. for training models and inferencing it, something like that. Yeah, and inferencing. So because when you train model, of course, you're going to inference it on whatever third-party application that AI model is going to be used. Inferencing. You can also say the AI person will be responsible for working with other teams, collaborating with other teams on projects. Let's see, collaborating with other teams. Uh, Collaborating with other teams. Yeah, just something like that. Okay. So you can now write maybe requirements. Okay, so this is something like maybe 3+ years of experience in building ML solutions. So you can say strong Python and skills, right? Experience since it's going to be building. So since it's going to be building models, so you can say strong experience in building models on cloud platforms. Okay, say from since it's going to be detecting fraud as well. I think you mentioned fraud. So you can say familiarity with fraud detection. Familiarity with fraud detection systems. Yeah, I think that's a key for the job description. So now that we have written the job description, so this is what we are going to be comparing the CV with to be able to extract relevant information from the CV. So now the next thing we are going to be doing is for us to be able to read this CV. How do we even start with reading the CV? So we'll start that by writing a Python function that can extract documents from the CV. So I'm going to define a Python function. I'll call it read underscore PDF. Don't forget, most CVs are in PDF. So you're going to pass the path argument into it because you are reading CVs, right? So by reading CVs, you cannot upload it in your code. I mean, you have to pass the path of where the CV is into the code. So here we are going to initialize the function we call the PDF reader. So this is supposed to be PDF reader. So here we have, for this the function, you see PDF reader function. So you're going to pass this, that's a function on its own. So you're going to pass it to a variable. So you call it reader goes to this. And the function takes an argument, which is the part of the file. Okay. So now we have done that. The next thing is text. Because this is because this is where the text of the PDF is going to be going. We are going to be extracting it and we are going to be passing it into this empty string. Okay, so now we say for page in reader pages. So why we are doing this is because we know that the reader function reads in pages. It reads documents in pages. So that's why we are using for loop to iterate over each of the page within the CV. So it's not a function, it's a method. So yeah, for page in reader dot pages. So you see, so we are going to use the page dot. So this page, it's since I said it's a loop, right? So the page that is iterating over each pages within the loop has a function called extract text. It's a very simple library. It has a function called the extract text. So it's this extract text function that we are going to be using, right, to extract the content of the PDF. Sorry. So I'm going to be I'm going to be appending on. I won't use append, but I'll say I'm going to be like it's iteratively adding this text into the text function, the text empty string. So here I'm going to be having page dot extract underscore text. Okay. So at the end of the day, we just return text. Yeah. So you can try this out before we proceed. Let me get the link to a particular document in my computer. Okay. Okay, let me use my CV. So I can find this somewhere here. So I'm going to call this function text. Let me see CV equals reader read underscore PDF. Let's see. So I'm going to pass the path of the PDF. I've copied the link, the URL of it, the link to the PDF. I've copied it. So I'm just going to pass the path here. Okay, so you have that here. So I'll just pass in the path. Don't forget that the function has an argument part. So you have to put in that part here. So then I'm going to print CV. Okay. Okay. So now let me run this. Minutes. Okay, so I've not installed the library. So let me just install it. pypdf. Okay. So don't forget you have to install required libraries before proceeding with anything. Okay. So now let me run this again. Okay. So we'll try to look at creating a virtual environment. Uh, so create a virtual environment. So because I just tried to install and you can see I'm still getting that error. Okay. So yeah. So say so, so create a virtual environment, put in those dependencies, like install them inside of the virtual environment so it can be easy for us to be able to run this code without issues. Okay, so PDF, ChromaDB, Okay, so let's install all of this inside the virtual environment. So let's check this. So, okay, so I made a mistake with my spelling here. That's the reason why. So I corrected that. Okay, so let's run the PDF extraction. Invalid syntax. Oh, sorry. From is supposed to be from. So I made a mistake there. Yeah. It's supposed to be from PDF PyPDF import this. So that was Chroma ChromaDB. So the spelling again for this was wrong. So that's the reason why. Okay. Mm, what's this again? So let me try to install that again. Anyway, the dependencies is still installing, so we just have to wait for that to complete. Here, we are done with the installation of dependencies. So let's run again. Honestly, this is very, very stressful. Okay, so you can now see that the text is being extracted, right? Yeah, the text is being extracted. So this is my CV, my personal CV. Yeah. Okay, so you can see this my name, my my phone number, and so on. So yes, that is that about that's to show us that that particular function is working. Okay, so once you are sure with this, then you can proceed. You can always proceed to something else. So I'll just copy this. Now move to the next. The next thing is want to define a function that chunks the text. So we cannot pass all of those texts I showed you earlier. We cannot pass everything directly into the LLM. We need to chunk it so that we can pass, small amount of information. When we cannot just throw the entire data to the LLM like that, or we cannot just vectorize the entire data. We need to put it into smaller bits, so which we call chunk. And while we are chunking it, we also ensure that there's overlap. The reason why we want overlap is because we don't want information to be lost. So just imagine we have a particular sentence chunked, we have another sentence chunked. Between the first and second sentence, there's information that is connecting both. So maybe the first information contains some information that is also present in the second one. By the time you are going to vectorize this and store this in the database, it is now going to be in form of vector. So if you are trying to ask questions relating to either of the two, then it's we will lose that information as a whole. So we want something like overlap. That overlap is going to help us to preserve the integrity of the information, to ensure that by the time we are asking questions, our questions can be searched and then we will find similar meaning to them within the database. So how that is going to work is that, let's take for example, we have 10 characters. So let's say A, B, C, D, E, F, G, H, I. Okay, probably this is 10. Okay, J. Okay, 10. This is 10 characters. Now, this is 10 characters. So we want to chunk it. We'll chunk this into two, but we'll have overlap of two characters. If you are chunking this into two, it means you are splitting it into 5, 5. Splitting into 5, 5, 5. You are splitting it into 5, 5. So meaning the first one will be chunked and the second one will be chunked. Right? The second 5 will be chunked. But don't forget I mentioned that we want to have overlap of two. That is, two characters should be overlapped so that we don't lose information between the two sentences. So how that will work is that you are going to first, chunk this one. Then the next chunk is going to start from the third down to the next 5. So until you have 5, 1, 2, 3, 4. Okay, so until H. Okay, that's how the second chunk will work. And then the last one will start from, since we have been overlap of two, then this will start from G up until the last end. So that's exactly how this is going to work. So we're going to put this into coding. So define a function. I'll call it chunk text. So passing argument text, chunk size, 300. So we want overlap of 50 text. Okay. Now the first thing you are going to have is you're going to define uh, an empty list where these text are going to be appended into later. Then receive starts from 0. Okay. Now what we'll do now is this. So say we are starting from 0. Okay. Now while starts is less than the length of the text. Why am I doing this is because, if start is less than the end of the text, that means length of the text, that means the text is we've not reached the end of the text. I'm using a while loop because I want this to proceed iteratively up until we reach the end of the text. So until the length of the text is 0, that is, we have no other text again within the that's when this while loop ends or it fails. So that is that. Then also we say chunk equals to text itself. So say starts from starts, that's from 0. Don't forget from the beginning. So here we are just trying to like index out within range. So if you have done Python, you must know that you can index within range. So starts plus chunk size. Chunk size. So here start is 0. So it means you are just trying to extract the chunk size at first. So don't forget later we are still the next start is not going to be where we are ending here. It's not going to be on this 300. It's going to be minus the overlap, which is 50. So meaning we'll be starting on the 250th character down to the end of the chunk size. So 250 characters plus 300, that's going to be, instead of 600, we'll be stopping at 550. So look at that. Um, the strip. So don't forget that it's also important to strip this because strip removes empty spaces before and after the characters so that our text can look more clean. Then also say if chunk, that is, if you're able to extract something, then we'll append. So this is chunks. Let's append chunk. Okay, so here we'll be able to append the extracted chunk into the empty list. So that's that. Now the next starts is going to be the starts. It's going to be chunk size. Sorry, don't forget we use chunk size. My chunk size minus overlap. Okay, so at the end of the day, we return chunk. Okay, so this. Hmm. Mm-mm. Okay, yeah. This is what is expected. Okay, I'll be testing this because okay, well, let's try it. Let's try it. I'll just comment this out. Comment this CV. I'll pass the CV as text. I'll say chunk text. Okay, chunk text. Mm, okay, chunk text. Yeah. Then I'll pass in the CV into this. I'll try to. Okay, equals to this. Let's say print chunk 0. So try to, since it's list, don't forget it's list and the text are being indexed into it. So um, I'll just try to index out the first one in it. So let's check that. dot py. Okay, so yes, this is so you can see this is the first chunk. This is the first chunk from my CV. So that's that. If I want to print the second one as well, you see that there are some overlapped text. So let me just try to do that. Uh, let me print this. Okay. Okay, so you can see the first text ends with a leading applied AI engineer with proven track record of over two. So you see where this one is starting. Engineers with a proven track record. So you can see engineers with a proven track record of shipping a record of over two, right? So you can see there's an overlap of text between um, here and here, right? So that is exactly what we want to do to prevent information loss. Anyway, that is that. So now the next thing after doing this is we want to um, we want to load our embedding model. Okay, we want to load the model that is going to vectorize this text. So you see, text does not make sense in machine learning. We don't need text. So what we need to do now is to convert to vectorize this text. Vectorizing this text means we are converting this into vector representation, such that text or text with similar meaning, have similar vectors. That they are on similar vector space. Okay, they are similar vector space, and there are models that can help us to do that. So one of those models is why we ported sentence transformer, okay, to be able us to vectorize text. So that's basically what we want to do. So I define a model to do that. Okay, so you say model equals sentence transformer. So there's this particular model that we're going to be using. It's called all mini LM, all mini LM L6 V2. So yes, so this is commonly used for RAG, but it's a it's a model that can help us to convert our text into vector representation. So this is what we'll be using. So for this, I'll just return model. I'll just return the model. Okay, so that's basically that about that. So now the next thing we want to do is to create vector embeddings. So let's store the chunk data into the vector database. What that means is we are going to vectorize the embedded data into we have not even embedded anyway. We are going to vectorize the chunked data basically into database. Just it's not something so difficult. Just think of it as storing normal data into a database, and I'm going to explain how you should look at it that way. So now the first thing is we are going to define a function, so which I'll call build index. Okay. So here we are going to have the chunks. Don't forget the chunks we had earlier. and the model. So this model is what we're using sentence transformer for. Now, the first thing here is you're going to instantiate the ChromaDB library, just like we are trying to initialize your normal SQL library or whatever inside Python code. So you're going to first instantiate the ChromaDB library. So do something like say clients equals to ChromaDB dot clients. Okay, so now that you have instantiated the ChromaDB library, the next thing is you're going to create a collection. So a collection is also same. We can refer to it like table in SQL. So if you are creating a table in SQL, you have to give it a name, and then you're going to name it, okay, and then probably describe how each of the features, column features, would be, their data types, and so on. So you're going to do something like that here. So I'm going to say collection equals clients dot create collection. Don't forget that we instantiate client the other time, so it's that client that we're going to use to create a collection here. So one of the arguments that this takes is the name. That's the um, name of the database. Okay, so you're going to call this CB chunks. Don't forget we have chunks our CB. Okay, then the next thing is you are going to have metadata. Now, I'll explain this metadata. So, why this metadata is important is because don't forget that we are dealing with RAG here, and in RAG, there's something we call similarity search, cosine similarity. So, cosine similarity is basically we are trying to compare the embedded vector space of what question we are searching, or the question we are giving to the database. So, we are just trying to do a similarity search between a question and embedded vector. So that's basically, and then we return the one that closely match. Simple. You're trying to do a similarity search between a set of questions that has been embedded into a vector form, and some other chunk data that has also been embedded in vector form. Then you are comparing this against a large amount of vector, and then you are trying to return the one that is closely similar to those large amount of vectors. So that's basically what we are doing. So in this case, we need to define H HNSW space, which is cosine similarity. So just say cosine. Okay, now, so we are going to define another thing which we call embedding. So here is where we are going to we are going to embed each chunks using list comprehension with follow. Okay, so here we have this. So say model dot encode chunk. Don't forget that this is going to be in form of a numpy array. So I want it to be in form of a list. That's why I used list there. So for chunk in chunks. Okay, so yes. Uh, okay, so yes, that gives me yeah, that's what I want to do. So use this sentence transformer to encode each chunks in the list. Now the next thing is want to get an ID for each of the chunks, so which is important. So I'll use formatted string here, which is very simple. Chunk, chunk underscore I for I in range of len of len. Yeah, I'm going to put this here. Range len chunks. Okay. Chunks. Okay, great. So here we are going to be having chunk one, two, three, up until the last chunks that we have. So that's the ID that we created for each of the chunks. So this is basic Python. Now the next thing we want to do here is we are going to add to collection. Don't forget the collection we created here. We're going to add to collection. Collection Let's add IDs. Don't forget the IDs we have here, so let's pass it. And then also documents. Documents equals to chunks. Then embeddings. Embeddings with what? Embeddings. Don't forget we embedded the vector here. So then with this we return connection. Okay, so that is basically how we can add the chunked vector into the database. Now the next thing left is to retrieve to write a function that helps retrieve this data. So don't forget that now we are going to try to retrieve information. So this is where the real work is. So you're going to define a function um, to retrieve or to do the similarity search and then retrieve from the database. So here we are going to be comparing the job description that we have with the CV. Okay, so such that we can get what's closely match the job description from the CV. So I'm going to define a function containing collection, model, job description. So collection is the database. Don't forget that was the database we defined earlier. The model is what we are going to use to vectorize because we are still going to vectorize the job description itself. Job description, then top key equals 5. So the top key represents like what's the top number of closely matched chunks that it should return. So because we are going to compare the job description with all of the chunks that we have from from the CV. So we compare it and return the top five. So starting from the first one so that we can see how closely match our job description matches the CV. Okay, so that is that. So now the first thing is we look at the query vector. Okay, query vector is what we are using to query the database. So we vectorize it as well. So we have query vector equals model. So don't forget I mentioned earlier we are going to encode the job description itself. Okay, so yes, this is how we encode that. Now the next thing after that is results. So here we are now going to do cosine similarity between this is where the real code is. So here we try to compare the query vector, which is this, to what we have within the database. So we say result equals to collection dot query. So you're going to query the query vector. So to do that, this has an argument called query embeddings. Don't forget that we've embedded the query vector itself, the job description, we've embedded it. And now it's now yeah an embedding, so that'll be the query vector. Okay, then the so which is a list, we don't forget that. Then because we used it to list here, so it's a list. So then the next thing is to talk about the n results because okay. Okay, yeah, so that's that. Then the next thing is we're going to define the chunks which is this. Now we are going to have a for loop to iterate over the results that we have, because now the result is going to be returning some very important thing, which is one, the IDs. Don't forget that we use the IDs to identify the chunks. So it's going to be returning the chunks that are similar to this query vector by their IDs. So you're going to be using that IDs to extract the text and the score, because for each of them it has automatically calculated a score of the cosine similarity between the query vector and all of the embedded chunk vectors. Okay, so we are now going to it has done that, has arranged them in an ascending order. So we are going to extract the top key, which is 5, like I mentioned earlier, and then we are going to extract their text, the text itself, and the score for them. So you're going to say for I in range of len results. IDs. Don't forget I mentioned that it's has identified them by we can identify them just by their IDs. So say chunks. Let's append. Okay. So here I have the text. So you can see results. So within that chunk, within this list, I'm going to be storing it like a JSON. Okay. So here I'm going to be appending the text and the results. Okay. So results documents. Um, okay. Then the next thing is going to be the score. It's going to be results. Yes. Okay, so don't forget that here we have. Okay, so here we have around. So here we are trying to get the score. So now this is another important thing for me to explain. So now the result is being um, done like from 0 to 1. 0 means like the distance between the embedded vector and the embedded chunk are similar. They are the same. They are very, very similar. That's what 0 means. While 1 means they are completely different. So it's just like between 0 and 1, right? Now, so what we are trying to do here is we are trying to flip that such that if the distance is, let's say 0, for example, then we can, it's going to be 1 minus 0, then we have 1, so that we can easily use that to convert it to percentage score. Do you get that? So that's why I try to round, subtract the result from 1 and then round it up. So I'm going to round it up by three decimal places. So that is basically that. I, okay. Yeah, so that's the about the test and the score. So now the next thing for me is to also loop. Okay, so here I'm going to loop over the chunks with the index and the chunk itself. So try to preview the chunk itself. So which is what we have extracted. For us to be able to see, don't forget that all of this text and score have been appended into this empty list. So I'm trying to iterate over this list to be able to preview the text and score themselves. So I'll say preview equals to texts. So I'm going to extract just the first 70 characters. Why? Because yeah, the first 70 characters. Why? Because I don't just want to see everything. I just want to see what it looks like. Okay. Uh, so I'm going to replace every new line with just empty space so that it can appear more neat. And then I'll just return chunks. Okay, so that's that about chunking, retrieving doing the similarity search and retrieving that. Now the next thing we want to do now is to generate the resume itself. So next thing we want to do is this. So I'm thinking of why not like let's instead of trying to compare the job description with the CV, like I talked about earlier, why not let's just try to generate, try to generate another CV from scratch. Why is because sometimes you want to apply for a particular role with their own job description and you have your CV, then you want to ensure that your CV fits for that particular job description. So this is something that could be useful. I feel that would be more useful. Okay, so let's take a look at that and then let's try to work on that. So what we are now going to do now is we are going to build a function that takes all of the scores, all of the information that is relevant to the job description, right? So we take them as a context, then we use that as a leverage for the AI to build upon. So here I'm going to define a function which I'm going to call generate underscore resume. So this is going to be taking job description into context and it's going to take retrieved chunk into context. Now, so the first thing is context itself. Context itself is we'll try to create some lines. Um, you don't want everything to be muddy together. So try to create some lines, you know, from there. Now we're going to append this. So here we are going to be having uh, okay, retrieve chunks. So yes, so that's context. So that's context is basically the text and the score. So that's basically that. Now the next thing we want to write is a prompt for the LLM to use to generate the CV. So you have something like this. Uh, so you have something like your. So the first thing when you are writing a prompt to LLMs, the first thing is you have to write the system instruction. System instruction is like the persona of the AI model itself. So you're going to tell it so like you are an expert in resume writing with over 10 years of experience hiring the team. Okay. Uh, so with this, it will be able to own that personality that it has 10 years of experience, hiring tech person. So it's something it will own, and that will definitely, of course, more experience is better when doing a task. So which means it's going to own that, and then it's going to behave and work in that direction. So here we are going to see a candidate as shared a CV using only relevant sections. So here we are saying write a tailored professional resume for the candidate. So that's what we wanted to do. Okay. Now, so you're going to put the job description here. So I'm going to say job description. So here we have it. Yeah. So say job description. That's true. Okay. So some what is relevant? So don't forget the job description earlier. So this is it here. Relevant section from the candidate CV. So don't forget that we talked about the retrieve chunks. So that's going to be context. Context. Okay. So now we are going to also give instructions for the LLM to follow. Let's say instructions. So I'm going to say something like tailor the resume. So because LLM sometimes they hallucinate. Hallucination means LLM writing what it's going out of the context of what it's supposed to do. So when you provided some set of information to LLM, sometimes they go out of that context and do something different. So you want to so by giving it specific instruction, it helps to prevent hallucination. So I'm going to write so tailored resume specifically to the rule above, right? I also say lead with the most relevant experience. Okay, so say things like use strong action verb, quantify results of this job. Okay, I'll say things like format with clear sections such as summary, experience, skills, education. Okay, I'll say I don't want it to write jargons or write too much, so I'll say keep it concise, uh, one page. Okay, so that would help the LLM. Then I can now say something. Right. Do resume now. Okay, so yes, that would help. Then the next thing I want to have within this is after writing the prompt, I would like to define the anthropic LLM. So I'll say something like clients equals anthropic dots and anthropic. Okay, so that is that. Then response. So I'm going to define the response of the LLM by saying response equals client. Don't forget to define client dot message dot create. So now listen. So for each of these things, you really don't need to memorize anything. You don't need to memorize. All you just need is, for example, you want to use Anthropic. You can just check um, you can check their documentation. We want to use library like this. Here we used this ChromaDB. Check their documentation on how to use it. You don't need to memorize anything. Okay, you don't need to memorize anything, but because this has to be short, and I have to take you through all of this. That's why I've also used them very often, so I can easily remember many of them clearly. So you can see model equals. So this is the cloud model released in 1st of October 2025. 2025 10/01, that's 1st of October 2025. So that's Claude icon. Max tokens equals 1500. Okay. Message was okay. So here row is user user and contents is what is prompt. So which is the prompt we wrote up here, prompt. So that is that. Then don't forget that we return response dot contents dot text contents uh, text. Okay, so that is that. So now the next thing we want to do now is to define the main function. So the main function will be responsible for putting together all of these functions. Okay, so you're first going to get the text. Don't forget the text you have up here. Where is that again? Okay, the text CV. I'm first going to get that according the read, the PDF function, and pass the path into it. Forget the paths we have here. So here we have the text. Now the next thing is the chunks. Don't forget we have the next function, which is getting chunks. So to get that, you define that. So here we are going to get chunk underscore text function underscore text function. So here we are going to pass in the PDF text into it. Then the next thing is to instantiate the model. That's the embedding model that we imported, which is sentence transformer. So we say model equals load embed. So we instantiate the model as well. Then the next thing is to pass in the chunk text into the vector database. Okay, so we call that collection. So to create a vector to vectorize the embedded text. So you have collection equals what do we use to define collection earlier? Build index. Build underscore index. So you pass this into say chunks model. Then so now we've been able to pass the chunk. We've been able to pass the chunk into. We've been able to pass the chunk into the vector database. Now the next thing is for us to be able to retrieve the top five chunk, right? Top five chunk. So for us to be able to do that, we call retrieved. Okay. So what function do we use to do that earlier? So retrieve function. Retrieve Okay, so we pass in the collection. Forget you have the collection model and job description. So collection, which is the vector database, then the model as well. The model we define up there, and then we have the job description. Okay, so you have the job. Don't forget to have the job description up here. Job description underscore description. Okay. Now the next thing is the resume. So to build the resume, so we have generate underscore resume function, the one we just wrote now. Now it's going to pass in job description, description, and then the retrieved data here. The retrieved that's the top similar content of the PDF with the job description. So that's that. Okay. Now the next thing is now print the resume. Okay. Next thing is to print the resume, and then once that's done, we print done. Stopped in our last session, right? By putting this there. So the only thing we just needed to do now is to invoke the main function. So which I'm going to do like this. To save this, and then let me clear this. Then we can run the function. Then don't forget that for you to do this, you have to add in your Anthropic API key. So you have created the client's variable here to pass in the API key. So it's that client that we are using here. Is the client that we are using here to work with all of this all together. So let's wait to see the output uh, of the API or the LLM. Okay, so I think that was because of where the API was. So let's try to put that. Um, let's try to put that inside this. So you do not have direct access to the API. So that's the reason why we are that. Okay, so let's put that here. So let's check this again. Why am I still having these issues with API key? Everything? Okay, so I still did that thing, which is unnecessary. So I instantiated the API key here. I did the same thing here, which is not necessary. So I think I skipped that, but that skipped my mind. Okay, great. So you can see what the output looks like. So here you have the professional summary, the core competencies, professional experience, okay, education, and all of that. So this is basically how we can, use RAG um, to generate resume. Okay, I hope with this you've been able to learn something about RAG. Thank you.